Okay, a small rocket probe in deep space. So there's no gravity here. We can just figure out the thrust. It has a mass of 68.5 kilograms, 45.2 kilograms of which is fuel. Its engine consumes 0.25 kilograms of fuel per second, and it has an exhaust velocity of 720 meters per second. For how much time will the engine burn? What is the initial and final acceleration of the rocket? Okay, so let's figure out the initial mass, right? Initial mass is 68.5. And then the final mass, let's subtract 45. 0.2 is 23.3 kilograms. Let's just check that. Sometimes I do my math kind of crazy. Yeah, okay, so that's our final mass, right? That's our final mass. This is our initial mass. Okay, that seems to me the next thing to do is to calculate the thrust of the engine, right? So let's do that. So force times time is mass delta V. Okay. I think I'm going to go with this. I don't know the time it takes to burn all that fuel, but I do know in 1 second it burns that much. So let's put 1 second in and go 0.25. Delta V is 720. And then the force is this. So now we can find the force, right? That's going to be this times this divided by that. 0.25 times 720 is 180 newtons, right? Okay. Then it said, oh, it does ask for how much time will the engine burn? Okay, well, we can do that. Let's do that here. Okay, so this is the thrust of the engine, which it doesn't ask for, but it does ask for the time, right? So the time would be 45.2 kilograms divided by its burn rate, which is 0.25 kilograms per second, right? So kilograms divided by kilograms per second would be seconds. So 45.2 divided by 0.25, I'm getting 180.8 seconds. Okay, so there's one answer. That's how long it'll burn, right? And then we need the initial and final accelerations. These are actually pretty simple because there isn't any gravity. We don't need to take the weight of the rocket into account. We can just say F equals ma. The force, the thrust of the engine is the only force acting on it, we'll say. So 180 is equal to the initial mass, 68.5, times the initial acceleration. So 180 divided by 68.5, and that acceleration is 2.63 roughly. Right, and I can do this because there is no force of gravity, right? And then I can find the final acceleration by using the final mass. We'll assume the force stays the same, and then the final mass is 23.3 times A. So I'll go 180 divided by, and I get 7.73. This gets a little bit more difficult at this step when it's taking off from Earth because you'll have to subtract, you'll have to go 180 minus the force of gravity. But we're in deep space, right? Deep Space Nine.